Hello everyone. So welcome to my channel. Today we'll learn what is Taylor series method. Now this comes under initial value problem. So see, first we have taken a first order differential equation. So first order differential equation means we'll see dy by dx. Okay. So I'm talking about this dy by dx, right? Dy by dx. So here we have taken that dy by dx equals to f of x comma y. So our right hand side is a function of x and y. Now this initial condition is very important. So we are provided with a initial condition y equals to y naught at x equals to x. So that means if this is the function y equals to f of x, so if we put x naught in place of x, y becomes y naught. Okay. So the value of x is x naught and the corresponding value of y is y naught. So this is the initial condition. Now one more thing, we are taking first order, okay, first order differential equation. So it doesn't mean that if it is of second order, then we cannot solve it by Taylor series method. So if it is of second order, then also we can solve it by Taylor series method, provided there will be one more initial condition like uh, x equals to x1 when y equals to what, y1. So there should be one more condition, okay, then only we can solve it. So this is dy by dx. Okay, so the value of dy by dx should be given. So here we will concentrate only on first order differential equation. Now let us see with these given conditions, the minimum with these initial conditions and the function, how we can proceed. So if y equals to f of x is the solution of the equation. Now see what is given here. We are provided with dy by dx. Okay, dy by dx is given. What to find? We have to find y. Okay, the first order is given. We have to find the value of y. So suppose dy by dx equals to some function f of x comma y. So you can write dy equals to f of x comma y dx. So if you observe this particular equation, no, then automatically it comes to our mind that if we integrate both sides, then also we can get the value of y. Okay, so in differential equation, under first order differential equation, there are so many methods: separation variable, exact differential equation, okay, linear equation of first order and first degree. So by applying those methods also, we can find the solution of this particular equation. But here, the similar type of equation we are asked to find under Taylor series method. So that's why we use Taylor series method. And also there are some functions. Okay, there are some functions. Suppose I'm talking about this function f of x comma y. So there are some functions which cannot be easily integrated, or it will not come under exact differential equation. Then what to do? Then you can solve it easily by Taylor series method. Now let's proceed. Okay, so this is the solution. Okay, y equals to f of x is the solution of the equation. Now, what is Taylor series? So we all know that the expression for Taylor series. So it is how much? Y equals to y naught. So y naught is, can also be written as f of x naught, right? So you know the formula from your earlier classes that y equals to f of x naught plus x minus x naught into y naught dash. So y naught dash means dash means our f of x naught dash, first order derivative. Okay, then x minus x naught square by 2 factorial y naught double dash plus x minus x naught whole cube divided by 3 factorial y triple dash plus dot dot dot. So here these y naught dash and then y naught double dash, these are nothing but derivatives of y equals to f of x at a particular point x equals to what, x. Okay, that's why it's not is given. Since we are putting the value x equal to x naught in the corresponding derivative, so they are denoted like this: y naught dash, y naught double dash, y naught triple dash, like this. So it will go up to sometimes n terms, and since it's a series, so we may write up to infinite terms. But don't worry, during problem we'll take fifth or sixth or sometimes seventh order, and after the other terms we'll neglect, because uh, if we proceed further, no, the terms are very very small, so those we can neglect. Okay, so is it clear? So what will be provided to us? So let us see. Will be provided with a function y equals to f of x, right? And then there will be initial condition y equals to y naught at x equals to x naught. Now what to find? To find y at some x equals to x1. Okay. At a particular point, we have to find the value of y. So that will be provided in the question. In the next example, we will see what is x1. Okay. So now let's see. Let us take one problem. Okay. So this is one problem, and we'll try to solve this. Okay. So find the value. Okay. Find the value of y at which point x equals to 0.1. So this is what I am talking about, x1, and also at another point, point 2. So this is also, you can write x2. So at this particular value will come later on to 5 decimal places. So whatever answer we'll get, you have to take up to 5 decimal places. Now what is the given equation? Okay, what is the given equation that, let us take. So here the given equation is this one, dy by dx equals to what? X square y minus 1. Okay, dy by dx equals to x square y minus 1. So this is the function. So this right hand side is nothing but f of x comma y, and this is the initial condition. Okay, so let us start. Given dy by dx is equals to x square y minus 1. Okay, this is the first order derivative for right hand side is f of x comma y. So what are the initial condition? Y of 0 equals to 1. So this is our x naught, and this one is our y naught. Is it clear? So in the method of Taylor series method, we have been given two initial values, x equal to x naught and y equal to y naught. So here 0 is our x naught and 1 is our y naught. Okay, what to find? To find y at which point? Point 1 and point 2. So at two different points, we have to find the value of y. Okay, now let us start the solution. So this dy by dx, we can write y dash. Okay, I am talking about this. Dy by dx can also be written like y dash, then x square y minus 1. Now if we put the initial values, so I am talking about x equal to x naught and what, y equals to y naught. So if we put y naught, so it will become y naught dash, and what about our right hand side? It is x naught square y naught minus 1. What is x naught? X naught is already given in the question. See, x naught is 0 and what, y naught is how much? 1. So if we put 0 here in place of x naught, so first term will vanish, so you'll get only minus 1. So this is the value of y naught dash. Is it clear? This one is the value of y naught dash. Now let us find y double dash. Okay. So these are all class 11 derivative. See, this is the first term, is in product method, UV rule. So first is x square and then y. So we have to differentiate this particular part in what, UV rule. So let us differentiate x square first, then it will become x square, sorry, twice x, and y will remain same. Next we'll keep x square as it is, and derivative of y is what, y dash. and finally we have minus 1. So since it's a constant, so the derivative of minus 1 is 0. So this is our y double dash. So now let us find y naught double dash. So it will be 2 x naught y naught plus x naught square y naught dash. Okay, now you see x naught is 0. Okay, so, and both the term involves x naught. So if we put x naught equals to 0, so it will become how much? 0. So our y naught double dash is 0. So like this, maybe some derivative will get 0. Okay, now let us find y triple dash. So maybe it comes to your mind that up to how much differentiation we have to find. So it's depending on 0. If we are getting more zeros, then you have to find 6 or 7. Or otherwise, if we are getting less 0, then up to 5 will be sufficient, because whatever answer we are getting, that is approximate answer. Okay, now let us differentiate this. So this is our first term, right? 2xy. So again we'll differentiate it in the form of u into v. So if we differentiate twice x, we'll get only 2, y will be same. And then now we'll keep twice x same, and derivative of y is what? Y dash plus. Now we'll differentiate this one. Again uv rule, x square y dash. So our x square, differentiation of x square is what? Twice x. Y dash will remain same. And then plus, now we'll keep x square as it is, and derivative of y dash is what? Y double dash. So these two terms are same term, right? So we can combine them. So it's twice y plus 4x y dash plus x square y double dash. Okay, so let us find y naught triple dash. So it will be 2y naught plus 4x naught y naught dash plus x naught square y naught double dash. So all the values we know. Y naught is how much? Y naught is given in the question. You see initial value. This one. Y naught is how much? Y naught is 1. So it is 2 plus. In the other two term we have x naught. So x naught is already 0. So our second term and third term will become 0. So we have 2. So third order is not 0 here. So let us find fourth order. Y4. Okay. So first term is 2y, right? 2y. Derivative of 2y is 2y naught plus 4 into, again see xy. So it's 4x. So 4, then derivative of x is 1. So we have only y dash. Next we will keep 4x as it is. Derivative of y dash is y double dash. Now we'll differentiate this term, x square y dash. So derivative of x square is twice s. Y double dash will remain same. Plus, now we'll keep x square. And then derivative of y double dash is y triple dash. So it's okay, one more mistake I have made here. This term, no? Derivative of first term is not 2y naught. This is 2y dash. Okay. So 2 is constant, derivative of y is y dash. So if we combine it, we'll get how much? We'll get 6y dash plus 6xy double dash plus x square y triple dash. So let us find y naught 4. Okay. So our y naught 4 will be 6y naught dash plus 6x naught y naught double dash plus x naught square y naught triple dash. So every time after differentiating, we are putting the initial values, that is x equal to x naught and y equal to y naught. So here y naught dash. So what is y naught dash? Y naught dash, if you see here, this will, this is y naught dash, right? This is our y naught dash. So y naught dash is -1. So it is 6 into -1. Other two value will become 0. The value of x naught is 0. Again, the last time also we have x naught. So other two values are 0. So what we have? We have -6. Okay, -6. So let us find one more. Y5. So now we'll differentiate this one is 6y double dash plus, if we differentiate this, you'll get 6y double dash plus 6x and y triple dash plus, let us differentiate it now, twice x y triple dash plus x square will remain same and derivative of y triple dash is y4. So if we combine some terms, then it will become 12y double dash plus 12x y triple dash plus x square y4. Okay, so now find y naught 4. So our y naught 4 will be 12y naught double dash plus 12x naught y naught triple dash x naught square y naught 4. So our y naught double dash is 0. You see, y naught double dash is 0, and in other two term we have x naught. X naught is 0, so here the whole value is 0. So again 5 is 0. So y naught dash is non-zero, y3 dash is non-zero, but other is 2, and then and 5 is 0. So y naught triple dash is non-zero also. Okay, so how many non-zero values we have? We have y naught is 1, y naught dash is -1, and then y naught triple dash is 2, and y naught 4. Okay, so we have 4 non-zero values, so we can stop here and then we can put all these values in Taylor series because we have 4 non-zeros. And if you want, you can find 6 or 7 also, but those values are very very small, so that value we ultimately neglect. So let us stop here and let us put all these values in Taylor series method. By Taylor series we have, so what is the formula? Y equals to, first term is y naught plus x minus x naught y naught dash, next is x minus x naught square by 2 factorial y naught double dash, x minus x naught square by 3 factorial y naught triple dash, x minus x naught cube by, sorry, this is 3, this one is 3, this one is 4, okay, by 4 factorial y naught 4. Let us write one more because we have taken up to 5th order, x minus x naught to the power 5 by 5 factorial y naught 5 plus dot 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 dot. Okay, so those terms are very very small. Now what to put? So see the question. So here what we are writing, just saying that we have to find the values for these two values, right? For these two values, x equal to x naught and x equal to 0.1 and at x equal to 0.2. So let us do one by one. Another value, you all know that. So y at x equal to 0.1. So wherever you see x, at that point we'll put what? X naught. Sorry, 0.1. Okay. So in place of x we'll put 0.1. So the first term is y naught. So y naught is already given in the question. This is 1 plus x. So in place of x we'll write 0.1 minus x naught is already given in the question in the initial value, which is 0, and y naught dash. Okay. So let us see what is y naught dash. Okay. Y naught dash is -1. Okay, y naught dash is -1. So it's -1 plus, next one is 0.1 minus 0 whole square by 2 factorial y naught double dash. So y naught double dash is our 0. So if you want, you can directly write 0, no need to put the other values also, plus next is 0.1 minus 0 whole cube by 3 factorial y naught triple dash. So the value of y naught triple dash is 2. Okay, y naught triple dash is 2. That value is 2. And then plus 0.1 minus 0 4 by 4 factorial and y4. Y4 again we have 0. Sorry, no, y4 is not 0, I guess. Yes, y4 is minus 6. So let us put minus 6. And this is your minus 6. Okay, minus 6. And the last term is again 0. You see, y5 is 0. So it's 0 plus dot 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 dot. So now you have to calculate it. Okay, you can use calculator also. So after calculation, you will get a value. If we calculate it, then what value we can get approximately? It will be 0.8. Let me calculate it. 1 minute. So, okay, and it is also given that up to 5 decimal places we have to take. So if we calculate it, we will get point is 1. No, first term is 1, then second term is your minus 0.1, then third term is 0, fourth term you will get like this 0, 0, 0, 3, 3, 3. The calculation part you also check 2, 5. So if you add all the numbers, so how much you will get? Adding all these numbers, so it's 1 minus 0.1 point 0, 0, 0, 3, 3, 3, and then finally 0.000025. So you get around 900,358. So we are writing up to 6 decimal places, no? So you can round up it 9003 and you can write 6. So this is the approximate answer. Okay. Similarly, in the same way, one more term you have to find 0.2. So you can put by yourself in the same way. Okay. Just in place of x, you have to put 0.2. All the other things are same. So here you will get 8.12345. No. So this will make 7. So this is the answer up to 5 decimal places approx. Okay. So it's very simple. Just you have to differentiate, keep differentiating it, and parallelly you have to find y naught dash, y naught double dash, y naught triple dash, and finally all those values we have to put in what Taylor series formula. So let us take one more problem. See, that time I'm talking about that that we can take second order also. So here I have taken one example of second order. So what will be the extra thing here? Two initial condition will be there. So this is one initial condition and this is our second initial condition. Otherwise we cannot proceed it. So here what is given? 2 d square y by dx square means y double dash. 3x dy by dx means y dash minus 9y plus 9. Okay. What are the initial condition? Y of 0 equals to 1. So this is x naught and this is your y naught, right? What is another initial condition? Y dash of 0 equals to minus 2. So this is again your x naught and this is your y naught dash. In the previous problem, in the very first step we find y naught dash. So here y naught dash is already given. So if this is not given, then second order you cannot solve. Okay, is it clear? So now let us find y naught double dash. So what to do? Just replace x by x naught and y by y naught. So our right side will become 3x naught y naught dash minus 9y naught plus 9. So I think all the values are provided to us. You see here x naught is 0. So first term will become 0. Then y naught. Y naught is how much? Our y naught is 1. So this is minus 9 plus 9. So finally it will become what? 0. So if we divide both sides by 2, so y naught double dash will become 0, dividing both sides by 2. So the first derivative which we find, which is y naught double dash, is coming here 0. So let us find third order, and then the other derivative we have to find here. So most probably, since double derivative is 0 here, so we'll get more zeros. So maybe we have to find up to 6 or 7. Now to get the third derivative, we have to differentiate this one, triple dash. So this right side is again UV form. So 3 into y dash plus 3x y double dash minus 9y, right? The second term is 9y. So if we differentiate, we will get 9y dash. And finally, the last term is 9. So if we differentiate 9, we will get 0. Now put y naught. So it's 3y naught dash. Okay, so you can modify it a little bit now. So these two terms are same. So it's 6y dash plus 3xy double dash. So this particular term, now it will become minus 6y naught dash plus 3x naught y naught double dash. So y naught dash, just now we got, no, y naught dash is given in the question. You see, I'm talking about this term. This term is already given, is in the question. This is our y naught dash. Okay, y naught dash. So from here you'll get y naught dash. Y naught dash is how much? Minus 2. So y naught dash is minus 2. So it's minus 6 into minus 2. And then in the second term we have x naught. So if we put x naught equal to 0, this will become 0. So how much we will get? We will get 12. So dividing both sides, since left hand side you have 1 2, na, we need exactly y naught triple dash. So dividing both sides, how much you will get? You will get 6. So this is the third order derivative at x equal to x naught. Okay. Now let us differentiate it again. 2y triple dash, let us differentiate it now. So it will be 2y4 and our right side will be 6y double dash. So again UV form, so it's 3y double dash plus 3xy triple dash. So after calculation, it will become 3y double dash plus 3xy triple dash. So now let us find y naught to the power 4. So how much it will be? Minus 3y naught double dash plus 3x naught y naught triple dash. Okay, triple dash. Okay, y naught dash is 0, right? You see here, this one y naught dash is 0. So first term will become 0. In the second term you have x naught. So this is again 0, 0. So if we divide both sides by 2, after dividing both sides by 2, y naught 4 is equal to 0. So here uh, so many zeros are coming now. Y double dash is 0, 4 is 0. Okay, let us find 5, fifth order. So y5, 2 will be there. So after differentiating the first term, you will get 3y triple dash plus, if again UV form, so it's 3y triple dash plus 3x y to the power 4. So first two term will be cancelled out, right? It's a very simple expression, y4. Now let us find for the initial value. So it will be 3x naught y4, y naught 4. So it's 0 again because x naught is there. Also y4 is 0. So since y5 is 0, so it's better that we'll find one or two more term. Otherwise, we will not get exact accurate answer. So if we differentiate it, now we are finding sixth order derivative. It is 0, 3, differentiation of x is 1, 4 plus then 3 x y5. So the initial value will be, so right side is y naught 4 plus 3x naught y naught 5. So here also you see you have y naught 4. Y naught 4 is 0, and in the second term you have x naught. So this is again 0. Let us find one more, then we'll stop. Because if zeros are keep coming, so it's useless that we are keep finding it. So it's 3 y5, then 3 y5, 3x y6. So how much it is? 6 y5, 3x y6. So the initial value is y naught 7. So our right side is 6 y naught 5 plus 3 x naught y naught 6. You see y naught 5, we have our y naught 5 is 0, and in the second term we have x naught, so it's 0. So let us stop here because all the values are coming 4, 5, 6, all are coming as 0. So now let us put all these values in Taylor series. By Taylor series we have, so y equals to y naught x minus x naught y naught dash x minus x naught whole square by 2 factorial y naught double dash x minus x naught whole cube by 3 factorial y naught triple dash. Since we are finding up to 7th order, so if you want you can write up to 7th order, but you see from 4th order onwards all the terms are 0, no? So after 4th order, so let us not write because all those terms will become 0, 4. Then let us give dot dot dot. Okay, so other terms will follow. Now let us see what we have to find the value of y at which point. Okay, again here also we have to find the value of y at point 1 and point 2. Okay, so let us find one by one. So y at the point x equal to point 1. So y naught. So y naught is already given in the question, right? Y naught is how much? You see, y naught is, yes, y naught is 1. Okay, and y naught dash is minus 2. So let us put them here. First term is y naught is 1. Then plus x, our x is 0.1, x naught is 0, and y naught dash is how much? Minus 2. These things are already given in the question. Minus 2. Then plus x minus x naught square, y naught double dash. So our y naught double dash is how much? Y naught double dash is 0. Okay, so since y naught double dash is 0, no need to put it. And y naught triple dash is 6, so that we can put. So this is 0. Okay, this term is 0 plus 0.1 minus 0 whole cube by 3 factorial. 3 factorial is 6. You can write 6 also. 6, and what is y naught triple dash? Our y naught triple dash is 6, and all the terms are 0, right? Other terms are 0. So now we have to calculate it. So if we calculate it, then we get the actual value. So let us calculate and check what will come. So let me find it. So first term is 1, right? And second term will be your minus 0.2, and our third term is how much? Is 6 cancel. Then how much you will get? We'll get 0.001. Okay, 0.001. So if you calculate it, how much you'll get? 1, then minus 0.2 plus is 0.001. So it's 801. Okay, so you can practice other problems also from any book, any numerical analysis book, or you can consult any engineering book. Okay, so I hope that this particular video will help you in understanding Taylor series, and thank you for watching the video. So I'll upload the other videos very soon. Thank you once again.